I'm Natig. I work at CGI as a mobile developer, and today I'm here to talk about clean error handling. So, as we all agree, probably error handling is important, and you might wonder why. Because things can go wrong, and when things goes wrong, we have to make sure that our code acts properly and our users don't get angry. So what's clean error handling in that case? Well, it's some next level stuff, and today I'm going to talk about some techniques that you can use in your code which can improve your error handling and which will help you to handle your errors in more clean and elegant way. So I took the points from book Clean Code, but I added some stuff from personal experience, and yeah, so that's what will be the points. So first thing is that we should use exceptions instead of return codes. So what does it mean? In the past, many programming languages didn't have specific error handling methods or exceptions. However, today we have exceptions, but back in the past, when there wasn't exceptions, people used to use error codes or error flags to inform the caller that there had something was wrong. Even though we have nowadays many programming languages which supports exceptions, still there are codes that you can see like this. Some people doesn't want to use them, and this is actually a code fragment from one of the projects that I have worked on. So as we can see here, this method is what it does is verifying PIN code and accepting the latest payment which is pending. However, the SDK developer which provided a library for us was returning errors as integer codes, and then you have to check everything and respond user accordingly and show different messages. And after that, you have to check payment verifications, last error code, which is again integer, and you have to respond user accordingly and show different messages. So as we can see, our main things here is verifying PIN code and accepting the latest payment. So what if the developer of that library, instead of returning integers, would return exceptions? Then our code would look like this, where it's clear that what code is supposed to do, and it's easier to read and understand. And handling errors, error part is separated from the logic for authorizing the payment. Yeah. So if you are using that kind of integer returning or error flag returning, you shouldn't, because it might make your code more complex, as we saw in the beginning. Instead, you should prefer using exceptions and throwing exceptions if there's something wrong with the steps. And yeah, then the next point is you should write your try-catch finally statement first. The reason is obvious, because if you are using exceptions instead of return codes, you should first think about the worst case scenario, which is when there's exception thrown by the method. So therefore you should write your try-catch final statement first, so that later on, if somebody reads that code, they would understand that there might be something that might not go smooth when they're calling the methods. Yeah, for that I don't have example code, but it's clear, I think. Yeah, the next point is that when you're when you want to handle your errors more clean and elegant way, you should use unchecked exceptions instead of checked exceptions. So you might wonder, like, what are unchecked exceptions? Well, unchecked exceptions are the ones, well, in Java there's two types of exceptions, checked and unchecked. And when you're using checked exceptions, you are forced to add to your method signature, either to your method signature, or you can handle that exception internally using try-catch block. But there are other type of exceptions which are unchecked exceptions, which doesn't, if you use those, then compiler won't force you to handle them separately or add them to your method signature. And I will tell what's the reason that you should use unchecked exceptions rather than checked exceptions. But I can show you generic view in Java how throwables are. So in Java there's three types of throwables: exceptions, errors, and runtime exceptions, and of course subclasses that you can extend. So as you can see, if you are throwing throwable or exception or other subclasses of exception, they are all checked. Therefore, when you are trying to create unchecked exceptions, you can use runtime exception or error. However, there's one unwritten convention that you shouldn't use error throwable types, because they are usually reserved by the system. For example, out of memory error can be example for that. So therefore, you should directly or indirectly use runtime exceptions. You can either extend it, or you can use, for example, illegal argument exception or similar stuff. And why it's bad to use checked exceptions is because it violates open-closed principle. And if you don't know what open-closed principle, then we can recap. Software entities should be open for extension but closed for modification. So why using checked exceptions would violate this is because, let's say you have created some implementation of class which throws one type of exception, let's say HTTP exception, and then when you are extending that class to add more functionality to it, and you see that there's more exceptions that you should handle or add to the method signature, then you have to change the main interface signature for the same method, which might be really bad when you have like complex system or large software. Therefore, it's not a good idea to use checked exceptions always. It failed, and also values that caused that exception. However, when you are creating informative error messages, you should be careful not to put there, for example, any sensitive data such as passwords, encryption keys, or similar sensitive data. Why? You might wonder why. Because when the app crashes or your software crashes, it's visible, the stack trace is visible by other users as well. So therefore, it's not recommended to put your sensitive data, put your user's sensitive data there. And another point for creating, handling errors more clean and elegant way is you should define exception classes according to caller's needs, which means that, for example, if you are calling some method which might throw many different type of exception, and you shouldn't care about those exceptions because your needs are different than the needs of developer who developed that third-party library. For example, there are different things that you can classify exceptions. It could be by feature, like what feature causes that exception, or you can classify them by the type that they are going to work with. Therefore, you should always try to wrap the exceptions in a way that your app could handle it in more easier way. So let's look at example for that case. So this is some code fragment that calls payments API get payments method, which should do over the internet, and it returns multiple different exceptions. But as you can see from the logic, we are not interested in the type of exception because we are just going to inform user with the code, HTTP status code for that error. But this library does not allow us to do that. So what we should do is we can create API wrapper, which is common practice if the API or third-party library you are using is not good enough for your needs. So you should always wrap it in better way so that you can in future change the implementations or change the third-party library totally. Yeah, so here we return, we have wrapper which calls the payments API, and according to each different type of exception, as you saw from previous code, we were returning the HTTP status code. So therefore now we are returning, throwing one type of exception, which is payments API exception, and which returns the error code with the message. So if you are using that kind of system that you don't need to handle many different exceptions manually, because you might have code duplicates or you might return different values than the exception returns, then you should wrap your API. And in that way, if we go back to main logic, you just call only one payment API wrapper and get payment exception, and then you can do whatever UI logic you want to handle. Yeah, and the next point is that you should always define normal flow. So what does it mean? Let's look at this sample. I took this sample from a clean code book, so it's worth mentioning. So let's say you have code that handles error case, but when there's error case happening, instead of stopping the user or giving them chance to retry the action, you are just returning different kind of value. For example, in this case, you get list of expenses from database and meal expenses object from database, and then you add the price to total that you created in your class. So this doesn't look good because you can do better, because we are only interested about this part, not the error handling part, because we are not really handling error, we are just returning some kind of default value. So what we can do in this case to make our code look better is we can create some class that will return value as a per diem, and database access object will handle it, and if it can't find from database that object, instead of throwing an exception, it will just return this instance of this class which has the default value returned there. So this is good practice in cases that instead of handling the error, you wanna just return some kind of default value, and it's called special case pattern, which is you should create classes or configure an object so that when there is different scenarios, it handles special case for you with the default values. So what can be example for that is optional wrappers in Java. Yeah, and we are almost getting to the end. When you are handling errors, you should take care of things that can cause errors as well. One of the things is returning error, returning null when somebody calls your function or method. So why? Because things are when you are returning null, the caller might get confused and might not even check for null values, especially if you haven't documented it. Let's look at one code example, which is again from payments API related stuff. And here, when user calls get pending payments, if there's no payments from pending list, then the method returns null value, even though it's documented here that it will return null value. But some developers just don't document it in that way or in their documentation that they provide. So therefore, when you are writing code which uses that get pending payments method, then you have to check always that if the payments weren't null, and then you should do actions on that, because otherwise you will get null pointer exception, which is unchecked exception, so that compiler doesn't force you to do that anyway. Could it be better? Yeah. Instead of returning null, for example, in that case, we are supposed to return list of payment objects, and we can use collections.emptyList, which will return us basically empty list, and therefore doing operations on that list is safe. And now we changed our nullable annotations to not null, because we assure the caller that this method will never return null, and therefore the caller of our code doesn't have to do any null check, and they will always be sure that their application or software will not crash because of some unknown error happened there. Yeah. Besides that, you shouldn't pass null values as well. But the thing is that many program, not many, but for example, if you take Java as an example, it's not possible to do not to pass null values there. So the values, the types are by default nullable. But for example, if you are using programming languages like Kotlin, then you can force the user to pass proper value instead of passing null. Actually, same goes for this don't return null point also, because if you are using Kotlin and you are returning not nullable type of object, then your developer will be always guaranteed by the compiler that there shouldn't be any issue with the return value. So therefore, it helps with the not passing null. But if we are using Java, so what we should do to prevent user from passing null values? So this is our pin code verification code, which does some logic with the pin code which is passed by the user. So as you can see, it's nullable because in Java the types are nullable by default. And what we can do to make it better is we can always do checks in the beginning before starting doing any operations, because then we have to put null checks internally in our API everywhere. So in that case, we can make our user to fail fast. Therefore, we can add runtime exception that when they run, they get proper message that pin was null, and they can fix it. And also, if you have noticed, I added there not null annotation as well, which also helps, depending on linter that you are using, that lint checks also can warn you about that hey, you are passing null value to not null like parameter. And yeah, now this piece of code helps us to fail fast and fix our issues in the code. And as I said, it's unchecked exception, runtime exception, and therefore we don't need to add any type to the signature of the method. Yeah, with those techniques, I hope they will be beneficial for you when you're developing your apps, and you will have less angry users because of random crashes. And thanks.